All right. Today we are going to see or solve problem regarding or on electrolysis, and not like to solve everything, but the basic ones that we really need for now. So the first thing is we're going to consider from the first law of electrolysis, which it states that the mass of a substance deposited during electrolysis is directly proportional to the quantity of electricity passing through the electrolyte. Now, mathematically, what we are trying to just talk about here is we said the mass of a substance is directly proportional to the quantity of electricity. Now, for us to do away or to remove this proportionality or limit of the proportionality, we have to introduce a constant and equality sign. Here will now be equal to K Q. Now, this K, which stands as a constant, we can represent it by Z, or it is always represented by Z, which makes it now to be the mass, which will be equal to ZQ. Now, with this Q, it stands for our quantity of electricity. Then this, it stands for our electrochemical equivalent. Then this, it stands for the mass of the substance. However, we can use this particular formula also to solve some problems regarding Faraday's first law of electrolysis. But we can also further expand it by saying that where our Q, it is also equal to IT. This I stands for current, and this T, it stands for the time. Now, if we're going to impute it back to our initial equation, it will now be this, which will give us ZIT. So generally, you notice that this is the formula that they usually use whether you want to calculate the mass. If it is the current, you make the I the subject of the formula. If it is the time, you now make the T the subject of the formula. So this is it. So if a question is given like this, given the electrochemical equivalent of a metal is 2.3 exponential minus 2, calculate the quantity of electricity that will liberate 30 grams of the metal, and they give you these options. Now, it is for you now to see how you can start calculating this. So the first thing that you're going to do is to bring out your data. Now, we'll write solution. Oh, what's happening? Solution. After that, now the electrochemical equivalent is given already, which is 2.3 exponential minus 2. Now, what again is given from our question? If you look at it, what again is given? We have the set mass. Mass given is 30 grams, right? Now, if you look at it, nothing again. They said we should just calculate the quantity of electricity. So the quantity of electricity here, it is not given. So because of this, you see, we are not provided with time or current. So we cannot use this particular formula. We cannot use this one here. We can't use it. But rather, we can use this. Why? Because we have this electrochemical equivalent, and we have this. We also have this. So these are the ones that we are going to consider now. So having said that, the next thing that we are going to do now is, let me demarcate this one here. We'll now see, using M that is equal to and we make this particular quantity of electricity the subject of the formula. That's what we are going to make now here. We want to make it the subject of the formula. So because of that, we divide both sides. So as I said, now when you divide both sides by this z, you are going to obtain this as our final result. Now let's see if we can substitute back into our equation, right? We know that now our q, right, our q will now be equal to, now the question is, what is our mass? Our mass is given as 30 gram. Now the next thing is, what is our electrochemical equivalent? It is 2.3 exponential minus 2. Now by the time you divide this, what you're going to now obtain, it is 1304.35, which is in column. So that means by implication our answer now, it is what? It is C. So we'll tick C as our answer. This is our solution, and this is what we obtain. So you see, we are done with this one.